In this video, we're going to be covering how to find the asymptotes of rational functions. The first type of asymptote is the vertical asymptote. So let's say we have this rational function, 2x divided by x minus 5 times x minus 2. Our vertical asymptotes are going to be the x values that we cannot plug in. So here in this case, the x values we cannot plug in, or the vertical asymptotes, are going to be 5 and 2, because they would lead to division by 0. Let's say we plug in 5 here, we're going to have 10 divided by 0. This is undefined, it's not allowed. That makes 5 an asymptote. Here, our asymptotes are going to be at x equals 5, x equals 2. Let's say we have another type, like 3x plus 4 divided by x squared plus 2x plus 1. All we have to do each time is set the denominator equal to 0. So in this case, we have a few choices. For x squared plus 2x, this 1 equals 0. You can factor or use the quadratic formula. Okay, for factoring here, what adds to 2 but multiplies to 1? That's just x plus 1 times x plus 1. So 1 plus 1 equals 2. 1 times 1 is 1. Okay. That's going to be x equals negative 1 as a vertical asymptote. Because when we plug that into here, we're going to get a result of 0. Okay. Now for the other types of asymptotes. For the other asymptotes, we have 3 cases to cover. The first one we're going to cover are the bottom-heavy functions. So let's say we have 3x plus 7 divided by 4x to the 4 plus 6. This is a bottom-heavy function because in the denominator, we have a degree of 4 right here in the exponent. But in the numerator, we have only a 1. 4 is clearly greater than 1, so this is a bottom-heavy function. Here, we have a horizontal asymptote, so like these horizontal lines, of y equals 0. That's our horizontal asymptote. And one thing to note is that sometimes these functions are translated by a constant. So if the horizontal asymptote of this whole thing is y equals 0, and we add a plus 2, this plus 2 is going to move up the function 2 units along with the asymptote. So this would become y equals 2. Let's do another example. Okay, here we have a bottom-heavy function, and the horizontal asymptote of this one in parentheses is just y equals 0. And we add 6, it moves it up 6 units. So y equals 6. Maybe note here that this one is y equals 0. Okay, now for the next type. There doesn't always have to be an imbalance in the numerator and denominator. They can be of equal degrees. As we see here, 3x cubed plus 5 divided by 6x cubed plus 2x squared plus 7. When we have equal degrees here, because we have a 3 and a 3, we're going to simply divide the leading coefficients. So this number divided by this number. So our horizontal asymptote is going to be y equals 3 divided by 6, or y equals 1/2. And again, if we have a constant, plus 2, we will move it up. So if our horizontal asymptote is y equals 1/2, and we add a 2, our new horizontal asymptote is y equals 2 and 1/2, which is 2.5. Okay, let's do another example. Okay, these are equal degrees, 7 and 7, so we can divide straight across. So y equals 3 divided by 4. Straight across being these numbers. Okay, and now for our final case, top-heavy functions. Okay, write the coefficients for synthetic division. You can also use long division. 2, 5, 2, 5 times 2 is 10, so we add it here. 12 times 2 is 24, 0 plus 24. Keep only the first two, and we're going to have 5x plus 12. And that's how you find vertical, horizontal, and oblique asymptotes.